bit about this tool that we wrote at Continuum. It's an open source tool called Odo. So if there's any Star Trek fans, hopefully you enjoy that reference. So it's a nice tool that we use a lot. Actually, I use it every day, nearly every day for a lot of the work that I do. So it's really about this kind of, yeah, I think the microphone's on. I have to be right here. Take it out. Okay. That feels awkward to me, so not a motivational speaker. Yeah, okay. So I think, Philip's here. He's one of the main core developers of Odo. We like to think of it as kind of CP for data. But for me, it's making my life less miserable. It's kind of how I'm going to set up this talk. It's going to be a little bit negative. I hope to not bring everybody down too much. Sort of. I'm not really going to commit to that entirely. So I'm Ben. Usually quasi-Ben everywhere. I work for Continuum. So I do some data science, I do some software development, among some other things. And this is kind of what a lot of us experience in our day-to-day life, this misery of converting data, moving data, converting, then moving data. It's a thing that we don't want to be doing, but it's what a lot of people pay good money to do. So we push onto our data scientists kind of this cognitive load. We were talking a little bit about this at dinner. So we say, I would like to hire a data scientist. I want all of this to fit inside of one person's head. That's a lot. There's way more than this, right? So we want not only to fit inside everybody's head, but be experts. Be experts in all these kinds of things. You hire a new data person, a new data scientist, and they need to be able to do some modeling. So you call out to scikit-learn. They need to be able to work with whatever your current setup is. So right now it might be PyTables, or it might be just a bunch of CSVs. And as your data grows, or as your company grows, luckily or hopefully, you might move over to a database. You might move over to these larger analytics engines. And then you just keep on pushing more and more knowledge into that one person. And that can be difficult. So maybe you hire a data engineer. And then they kind of can cut off this scientific computing, maybe, but it's still good for them to know about it. They still have to exist in this distributed systems world or this database world and still collect all this information inside of their head. So it kind of looks like this, right? This is the textbook that you would have to if you went to school, that's what the data science textbook might look like. So Daniel's he's right there with his hand up. He's also somebody that's trying to exit out of misery. Oopsie. This is him. Right, and for those that remember Susan Powter, stop the insanity. So Odo is a tool that maybe can help me with some of these things, maybe. And there's actually a ton of really good tools that can manage and move and convert data that already exists. So Pandas is really great. CSV Kit is a pretty great tool if your kind of world is CSV. And you also have a Unix environment. There's this other tool called Dataset, which is really great for just working with databases, mostly Postgres. And then there's this other tool down here that I wanted to highlight called DAF. DAF's a really great tool if you have a bunch of CSVs that you need to merge together, and there's a bunch of there's rows that are incomplete. It basically does a diff of your CSVs, and you can select through it. These top three tools are written in Python. This one's written in Node. So I guess there's that. So these problems kind of expand, or they go beyond just a single language, a single use case. And then actually, there's a bunch of, if you go onto Hacker News, you go anywhere, there's a bunch of people that reject all tools and say you should live entirely in Unix and you can do everything on the command line. So James is quite deft at doing command line things. If you saw in his talk, you can potentially learn all this and collect all this inside of your head of how to do everything here, so from cat to tail, and everything here with the magic of pipe. You can do a ton of different things if your entire world is flat file. But you kind of have to be creative. It's not like a one thing that does it. You have to fully grok each one of these tools and all the args associated with each one of these things. It's also quite a bit. So we still have problems. So we'll start with this, what was maybe the canonical example of data munging. Of I need a CSV, I need to load it into memory. Right? So how do you go about doing that? So if you want to stay pip installable, so pandas, I would argue, is not exactly pip installable, but well, maybe now it is with wheels. So we'll just stay entirely in Python. So how would you read into CSV? So you'd call out to something that looked like this. You'd open up the file, you'd pass that into CSV reader, and then for every line, you'd call next on it. And then you'd munge and get money, presumably. But actually what's happening here is not very useful because it's just loading everything in a string. So for every line that's there, your ones are strs, your 1.2 is stir. That's not how we actually work with data, right? So we call out to this very popular concept, the data frame. You just read in the CSV. So they took this idea. I just want a single line, just the path to the file. They read it in. I spent a little bit of time in NumPy land before I came to pandas. The load text or load. There was another one. What was the name of it? Load txt, and there was also something else. What? Gen from txt. Yeah. Those ones didn't really work quite well. So you still you wanted to take the CSV and you wanted to load it into a NumPy array. Pandas made that really easy because it already had these concepts that record arrays didn't fully kind of work with. And actually, people went kind of wild inside of this framework. They realized, oh, I can do a bunch of other stuff. I want to take a lot of different things and bring them into Dataframes. R does this too. A lot of other tools do this, but we have this framework that we can now kind of push on. We can offload this problem onto other people to say, oh, I want to also work with Excel. So somebody else can write the read from Excel file. And then I think that calls out to XLRD or some other underlying tool. But me, the developer, the modeler, the data scientist, I don't really care what's ingesting it. That problem's already solved for me. Somebody hands me Excel files, I can read it in. We have all these other ones in here. So we get kind of esoteric message pack, maybe read from a pickle of a previously pickled data frame. We even have some nice things down here, read from SQL, so I can grab a SQL table and just bring it in. We also have these output functions too. So often we found ourselves, the collective we, find ourselves in this situation where I pull stuff out of whatever file it is, whatever database it is, I do some munging, I do some modeling, and now I need to push it back in. So somebody wrote these two methods. And again, that problem was also offloaded onto a bunch of other people. We had this framework where we could write this to method, figure out what this data frame looks like, and then to CSV, to Excel, to dict, to SQL. It's sort of solving that problem. But you have to exist entirely in the data frame in order for this to work. So how would you deal with a pile of CSVs? That's something that I'm handed a folder of CSVs, say, do something with this. Bring this into a data frame. So you do something that looks like this. You have a list, you grab a glob of CSVs. In this case, I might have lots of iris data. So that'll be kind of like the example throughout a lot of these slides. And then you append to this list all these data frames, and then at the end you can cat, right? So Philip also is a core dev of pandas. I asked him, can I just stick this function inside of pandas? Why isn't this part of read CSV? Why can't I just hand it in addition to a single file of CSV? Why can't I give him a pile of CSVs? And the answer is quite reasonable. It's like that's not kind of out of scope within the pandas world. We do this one thing really well. Let me do this one read CSV really well, and not do like hand. I mean, have anybody looked at have you looked at the list of args for read CSV? It is extremely complete because there are so many problems with CSVs. Adding this load just seems kind of unnecessary. But now I have this function, and this is something that a lot of us do. We're all writing these like same 5 lines of code. It would be nice if I also had another framework where I could codify these same 5 lines of code and add it to the general knowledge base, or actually remove it from the general knowledge base. Just say, here's a pile of CSVs, convert it to a data frame. So take this thing, this glob, wrap it in a function, maybe read CSV dir, and now I have this function that I can pass around to all my friends. Right? They don't have to worry about writing these 5 lines anymore. But this is very simple. I mean, this is just sort of a motivational case. It's very simple. So codify this function in the framework. This is what we do with Odo. So Odo can just take a pile of CSVs and just call pd.dataframe, and it gives you back a data frame of all these things. It does the things that are a little bit smarter than what's right here, but that's generally the idea of if you looked in the code base, you'd see something that sort of looked a little bit like this. You take this pile of CSVs, you're reading them in, it's actually going to be a chunked reader, and then you just kind of concat all of them together, and then you hand it back to the user. So we can take that concept and extend it to lots of other things. So let's talk about databases. So there's a DBA. I think Mahesh is a DBA. So I've worked with him in the past. These are, I don't mean to be judgmental about some of these things. But the DBA's life maybe is filled with misery, sometimes. So the MS SQL, yeah, the MS SQL DB is maybe, he's pretty sad, or she's sad. The MySQL person, well, there's so many, MySQL is the most widely used database in the world, so say Google, I guess, because they use that. Postgres people are generally pretty happy. They're kind of ecstatic. You can do any, Postgres people are always happy people. MongoDB people are just like crazy, so they're super ecstatic. I suppose like I've heard people say disparaging things about Mongo, like it's a database for JavaScript developers. And then Oracle people are also really ecstatic. If you live in Oracle, it basically invented the database. Well, not invented it, but they've just done everything. So if your world is Oracle, you can do everything inside of that database because it's already been done. The schema's already written. So overall, DBA might look like this. But maybe we can learn from that kind of misery. You're not a DBA. So we don't expect that kind of knowledge. Like if you need to write to a database, how do you do that? Are we going to push that load back onto you as the modeler, as the scientist, the statistician of working with databases? So there's some of that. There's some kind of SQL fetching that we expect from those kinds of people. Oh, that didn't work out too well. Those are supposed to be more emoticons. So you're not a happy person. And again, we reference this stack. We're trying to reduce the pages in this book. So how do we work with the naive way of working with CSVs if we want to take a CSV and put it into a database? So if we did this with the iris example, we'd grab a cursor. Again, we don't have a DBA. We're somebody within a large organization, or we're by ourselves. So we have to create a table. Then we have to have some function of read in the CSV all the strings. So maybe that's a pandas read, or maybe that's the Python one. And then we have to do this insert into the database. But notice that we didn't get anything free. Everything had to be written. Everything had to be understood about all the data everywhere. So we had to say, so databases are strongly typed. Actually, SQLite is not strongly. It doesn't enforce types, which is can be lovely. So you can shove strings into ints. You can put ints into strings, and we'll throw an error. This is not great, right? So we want a tool that can collect a lot of this knowledge. So pandas was sort of has gone down this route a little bit. It does a read of the CSV, and then we have this toSQL. So we still have to create the cursor, the connection to the database, and we hand it a table name. But the data frame has hanging off of it this toSQL method. So now I can, if I can get everything into a data frame, I know that I can easily push into the DB. So that's pretty great. So Odo can do that, right? Odo can take a pile of CSVs or a single CSV, convert it to a data frame, and I can push to SQL. But that's still kind of that's not exactly what I want, right? Like under the hood, there's a lot of things happening. The toSQL does type conversion, so it figures out, right, as part of the data frame, when you load in ints, it gives you ints. And then it also has to do a mapping of what the NumPy data types are. So a NumPy int, what does that convert to for the database? So in SQL, it's calling SQL Alchemy actually. So it grabs this from types. SQL Alchemy has this very big type system for all the different databases. So for Oracle, you can be very specific, but those specifics of that type system is different from Postgres, which is different from MySQL. And nothing, as we just heard, kind of exists in SQLite. But it does this kind of mapping of an int or a float in NumPy world to what that int and float are in DB world. It figures out the columns that you want, and then it does this chunked insert, which is kind of nice. Did you have a question? Okay, sorry. If there's any questions at any time, please feel free to interrupt. But I knew a DBA. She said bulk loading is a thing. So again, I have this CSV. I want to get to a database. Why am I reading into pandas just to get to a database? There's all these bulk loading methods that I can take advantage of. Database misery is long and extensive. I should take advantage of all the misery that they have gone through. They went through all the same things that CSV reader and pandas and every other thing that had to deal with CSVs long before us. So when you look at these copy methods, each one of them has the same sort of parameters that you'd expect. What's a little annoying about this is that there isn't kind of unification between all these different databases. I have to say copy from for Postgres and load data and bulk insert. And actually this thing right here, BCP, so the Microsoft people a long time ago were like, oh, I often have to do this thing where I take CSVs and put them into databases. I'll write a tool, a command line tool called bulk copy. It's called BCP. This came up a little bit when we were trying to rename Odo, because we wanted to name it BCP, and we just happened to find it. And even SQLite has a bulk loader. It's .import if you're actually in the shell. And it looks a lot like this. So this looks like a lot of the parameters that you have from read CSV. You have copy from a table name, the delimiters, whether there's null characters, the quote, the escape, headers, encoding, all these kinds of things are already built into these bulk loaders. Wouldn't it be nice if we just wrapped up this entire thing inside of a function? See where I'm going with this? So Odo does that. It takes in your CSV, does a little bit of sipping of what the data is, looks at the first couple lines, figures out if there's a header there, but you can always pass in some more information that there is a header, this is the encoding. And then when you call out to Postgres, you still have to provide some auth. It just does a bulk copy for you. So not only have we reduced the amount of lines that we have to write from 5 to 1, we've reduced the memory that we have to deal with from whatever it is to read into a data frame to 0. This is, I don't know, like 20x faster because it's hard coded into the database. Like it's written as fast as it possibly can be. We should be using those kinds of things. So CSV to DB. Oh, right. So Odo, a framework for leveraging other people's misery. So if you're miserable, don't let other people be miserable. Codify that knowledge and let other people kind of move on with their life. But so if you so I think Andy Terrell, I saw he tweeted this out as overheard, I guess. I don't know who said it. If you let people go to Crazytown, they will every time. So we can do things like read in a collection of CSVs into a database. We can take JSON blobs and put them into Mongo. Right now there isn't, if you want to submit a PR, Postgres can handle JSON. Submit a PR and we'll put that in. But this, when I look at these kinds of things, this is just a URI. This is the full URI that I could possibly give it, a username, password, hostname, port, database, table name. That URI looks very familiar, makes me think about SSH things that I might want to do. I have a username, a password, and a port. So what stops me from using Odo to just copy to another machine? There's nothing. So we did that. That actually becomes very useful, it turns out, because if you are on Windows and you don't have SCP installed, from the command line, how do you move things around? Or from the Python prompt, how do you move things around? Odo can do that. It's not specific to these Unix things. I'm getting a lot of weird looks, and that's exactly right. Why should we be able to do this? Well, it turns out it's really useful if you ever need to deal with remote machines. So if you are somebody that's asked to, say, set up a Hadoop cluster, and you have this pile of CSVs on your laptop, which is actually often the case if you're not kind of like in production rolling, you're trying to get things up and running, you're often in this situation where, okay, I have some like example data here. I need to push to an HDFS cluster. How do I get it on there? Well, maybe you live in a VPN where you actually have SSH access, so I need to move it up there easily. So we now have this other mechanism of moving things there. We'll come back to this, but essentially, Odo becomes this place where I can do sort of a copy from anywhere to anywhere, as long as I can write, these kinds of functions. So this is using Paramiko. Paramiko implements SSH2 protocols. So that's why I can get it on Windows and anywhere else. I don't have to call out to Unix SCP. And I've now taken these 3 lines, and I've wrapped it in this function that takes in a CSV, a text file, a JSON blob, anything that I want, and it just sticks it on the machine. The other nice thing about this is that I can pass it, I don't know, with SCP, sometimes I forget whether or not I can use the key file or if that's rsync. Like rsync has some weird parameters where you have to like SSH in, but then rsync. I don't know, maybe other people kind of can keep that in their head. So let's talk about the cloud. I hate the cloud. It's a terrible place. So we invented this new word. There's not a DBA, there's a data engineer, maybe. I've seen a couple of people that call for data engineers. So there's HDFS that exists kind of as this data engineer person, or maybe a Hadoop administrator. There's a lot of kind of lateral transitions between DBA and HDA, I guess. There's S3. That's a pretty popular place to store data. And there's Redshift is also pretty great. So, and there's these other things that we rely on, these other kind of weird database or analytics engines like Hive and Impala. So the HDFS person's pretty unhappy. Every time if I need to put data into HDFS, what do? So if I use a command line tool like HDFS, then I have to write this really weird thing. I have to write HDFS, DFS, -put, the file that I'm going to, and then the folder there, right? It's this weird mapping. But that's really slow because HDFS is implemented in Java. So every time I want to write from the command line, just to move a file, I have to spin up a whole JVM. That seems terrible. That's like, you could do better. You could do much better than that. The S3 person's pretty happy, actually, because it's just, I can put whatever I want there. It's just a key value store. And the Redshift people are also pretty happy too, because it's just Postgres underneath. We all love Postgres. But then Hive's this weird analytics engine. It's a database that kind of layers on top of HDFS. They're pretty unhappy because it does a lot of very strange things. It can be hard to deal with. So Hive is this language where Hive is both an analytics engine and this metastore where you write SQL. It translates to a Java MapReduce job. You get really weird errors. Moving data in and around HDFS can be strange if you kind of do a delete. So Hive gives you this prompt that's like a database prompt. So if you delete a table in Hive, what does that mean for the underlying HDFS? It can be a little confusing. And Impala people, I think, they're almost happy, but Impala depends on kind of the Hive metastore, so they're not totally happy. So overall, data engineers are unhappy. And that's because emoji algebra is really weird. I don't have time to go into it, but there's various properties that I couldn't do. So how do I move back and forth between Cloud HDFS and data? So we have this pile of CSVs. I can write with Odo this one line. I can say, take this CSV and put it into HDFS. And the reason that I can do that is because if you have web HDFS on your cluster, web HDFS gives me a non-JVM interface into HDFS. And it has primitives like read file and append file. So all web HDFS is just passing, it's just a REST endpoint, and somebody nice enough wrote this Python interface for us. That's pretty wonderful. If you don't have web HDFS running on your cluster, and I would like to change this within the Odo source, is this other tool called Snakebite, which uses protobufs. So again, you're still getting 20% faster than just doing an HDFS put. Or that's what they claim. And I've also seen things like that. But now we can kind of go crazy. We can take these small functions that we've seen before. We can codify this knowledge of moving data in and out of S3. So if you use Bodo is a Python library where it has things like set key, get key, all these things. I can move data in and out of am I doing? In and out of S3 buckets. I can move data in and out of HDFS. I can even move data in between HDFS and Hive. Since Hive is this SQL query-like language, it has primitives also like bulk loading. It has things like load data in path. It has a very MySQL-like interface. So you can say, from this kind of folder of CSVs, define this table on top of it. And this was something that I was doing a lot because I wanted to work with Impala, and I had other people that were on our teams wanted to work with Impala, see how fast we could push it. And even within there's some other parameters here that Hive also has things like store as Parquet, store as Avro, store as ORC. Are there Hive experts here? Maybe, okay. So nobody loves Hive, no love for Hive. And then same thing with Redshift. I can also take this thing and push it into Redshift. So now we're kind of going really crazy. Our network is pretty big of things that I can do. So let's talk about binary stores. So this book of knowledge is pretty big. But actually, maybe I should pause just for a second. So who here works with binary stores? Like HDF5 or bcalls, MPZ files. So there's a few people. Are you scientific programmers? Yeah, maybe some academics that work with those things. So there's this whole other world of binary stores that are very popular amongst like the academic crowd. Physics people use them. They don't ever work with databases. Very rarely do they. They work with these things called HDF5 and bcalls and maybe Parquet. And generally, these people are super ecstatic. These files, they're small binary files. They're portable. They're tabular. Some of them columnar. They're compressible. They're chunked. I can do all these really amazing things with these binary stores that I can't easily do. I don't need a whole database to do these kinds of things. So maybe there's some knowledge gaps between the web world and the scientific compute world. And they go both ways. But there's still problems here. So HDF5 has some issues. There's a couple different interfaces into it. So there's PyTables, which is pretty great, interface into HDF5. If anybody uses HDF5 within Pandas, there's this specialized HDFS store, which you can't just read from PyTables. So Pandas does something special. I think Philip was telling me before, it's because there's no datetime type in HDF5. So you have to convert your datetimes into ints. And then there's no var-length strings. So you're kind of hosed on that. And then bcalls actually is this new thing, but it doesn't solve missing data. There's some rough edges, and it's still new. But if you do array-oriented computing, or if all of your data can be kind of vectorized, or just 5 minutes left? 5 minutes left. Oh, okay, I took too long. And then there's another thing called Parquet. But there's no Python interface to it. But Parquet is really popular in the Impala world. It's really popular to take all this HDFS data and see if you can compress it and make it columnar. Then you can do really fast selections. So I think for as much hype as there is around Spark, if you can live in this world that's just SQL-like functions, kind of joins and merges and group bys, Parquet and Impala are pretty impressive. So overall, the binary store people, maybe they were super ecstatic, but there's still some issues. So Odo, again, takes care of this problem. I can move in and out between all these different kind of binary stores. I can go, in addition to all these conversions, I can also go from Dataframes and NumPy Arrays. There's some places where this is going to break. File a bug report and we'll fix it. But it's pretty great. So how does all this work? Do I have to write? I think maybe I'm getting mad. So I can do this. Right now I can do this. I can take an S3. I can take something in S3 and I can shove it into a Postgres DB. That can be really great if I'm running if I'm running giant batch jobs. I shove all the data back into S3, but I don't want my web front end to be S3. I want my web front end to be Postgres, so I need to get the data back out. Do I have to write every single conversion for every possible path? The answer is no, but I don't know why it says yes. Oh, does this work? Yeah. Okay. There we go. Okay. So the question was, does this work? So the answer is yes. How? How? So actually, it works like this. So this is all the possible paths that everything can take. So if I hover over one of these things, like Odo CSV, the outlinks are in green, the inlinks are in red. So from Odo CSV, I can go to everything here. So underneath the covers actually is this NetworkX management of all these different endpoints. And you find the smallest path between one node and another. And you write conversions between them. So we saw a couple of those conversions before. That's just the function that I'm going to take from a CSV to a data frame. And then there's also these, how do I move data around? It's just appending in one place to another, so that HDFS append file. So here's how much, I've got like 0 minutes left, but here's how you might go about doing this thing. So I had this, so often I also was in this case where it's like, here's a CSV file out in the web, right? There's an endpoint called, often it was like stored on a GitHub repo. So it's, I first had to remember it's raw GitHub user content, all this thing, and here's an endpoint. Put that into a data frame. Right? It's actually not such a new idea to be able to say, call out to some web endpoint and stick that in a data frame. Pandas already does this. So you can call it to Yahoo and Google and just pull that right into a data frame. You can do this with other kind of finance resources. But I wanted to do it for all these CSVs and JSON files that lived everywhere. And I was getting very tired of right-clicking or downloading to the download folder, only just to put it into a data frame. That's all that I wanted to do with it. And then I have all these latent files that I need to clean up. And they're not big. They're just kind of like adding to this larger pile of misery that I was experiencing. Like I just have files kind of everywhere. It was very annoying. So I can solve this with Odo, because I can go to Crazy Town and nobody's stopping me. So there's 4 functions, but there's really 5 functions. And the 4 functions that I need to implement inside of Odo are discover, convert, append, and resource. So they're very simple. I mean, in terms of at least explaining what they are. So discover just figures out it's going to be the type system. Convert is how I move from one type to another. Append is how I get data from one location to another. And then resource is how I kind of codify what that URI looks like. And then drop is this optional one where I can kind of delete it. So I can drop a table, I can delete a file. You can't drop a URL, obviously. So here's how I do it, right? This is just the small function. This is actually taken right from the code base. Just open up the URL and then write it to a file. Discover is something that I get free from datashape. So I sip a little bit of data, and then I just try and discover on what those types are. Sorry, I'm just trying to go fast, but I can just, because I guess I'm holding up lunch. Convert often is just about getting into these temporary locations. So if I go back to here, if I get the sort of promise that we try to make is, so I have this URL, and it's a URL CSV type, sort of, I can go into that, but the promise that this network tries to give is, if I can get from any other node into this network, I can get anywhere else. So from URL CSV, if I can get to a temp CSV, it's just this thing that we've codified within Odo of saying, just store it to a temporary file when you're done using that resource, garbage collect it and delete it. Then I can get anywhere else. So from a URL, I can go to a data frame, I can go to HDFS, I can go to S3, I can go to SSH. I can do all these things if I provide the right parameters. So that's what I did. Or yeah, that's what you can do now as well. So take a URL and put it right into a data frame. Take a URL, put it right into HDFS. So here's just some last closing thoughts. So frameworks are great, right? Learn my abstraction and your life will be easier is kind of generally how I think about frameworks. Odo maybe is this place where I can write a very small function. I can move and convert data. Hopefully that misery is kind of gone from my life. There's a lot, for as much science as there is in data science or computer science, there's still a lot of folklore out there. Databases require DBAs. That's not really true anymore. You can install, if you're doing something small, if you're just a small research group, you're not doing transactional data, you need to work with it. You need to do like efficient joins or things like that. Databases are really powerful. You should be using them. Another one that I alluded to earlier is that there's kind of this general knowledge that Mongo sucks. You should go try it. It's really easy. Somebody's shaking their head, but you should. Like my knowledge is dependent on kind of what somebody else told me. Somebody told me Mongo sucks, and I've kind of repeated that. We can verify those things very easily now. it might suck for you, but it might not suck for these other people. And then there's some other things. There's these gaps in knowledge, like the academics and the scientific computing people like know about these binary stores. Why don't other people? You should use those kinds of things. You can do a lot of really great work. You can run a whole website off of a single SQLite file. That's not a binary store, but that's extremely portable. bcalls maybe is also a place where you can run a whole website, but you can do a lot of, if your data is just a bunch of vectors, you could do a lot of reading from that and just shove that into some JSON, and you can do that with Odo. It's not too bad. So Odo ultimately is a place for happy people. It's not so miserable. Yeah, I think I'm done. Okay, thanks.